Consider an LED, subjected to a supply of 15 volts, but designed for about 2 volts and only 30 milliamps of current. LEDs are a common light source, and for such a purpose they must be reliable. As with all electrical components, however, they must be treated with care. To simply manipulate the voltage and current responses throughout this basic LED circuit, controlled resistances can be introduced. Informally, resistance describes the ability for a voltage, similar to an applied force, to affect a current, similar to a resultant movement, in a circuit. Think of it as a source of friction, which resists the flow of electrons despite an input of energy, such as from a battery. Like friction, heat is dissipated in the process, and the higher an object's resistance, the smaller will be its current. Specifically, resistance is defined as the ratio of the voltage across a component to the current flowing through it, with the unit ohms. Note that this is not Ohm's law, which restricts the resistance to be independent of voltage and current. In a conductor, resistance manifests due to the collisions between the conductor's electrons and the lattice structure of the conductor's atoms. The influence of these collisions is exacerbated by a more energized or excited lattice, and hence higher temperatures increase a conductor's resistance. This characteristic is denoted with a positive temperature coefficient. In other materials, like semiconductors, a negative temperature coefficient may emerge, whereby resistance decreases with an increase in temperature. The additional thermal energy frees electrons so that they may conduct, unlike in a conductor where a sea of free conducting electrons already persists. This disparity in physical structure alludes to the material dependence of resistance. A more fundamental property then, termed resistivity, specifies a material's innate ability to oppose electrical conduction. On this property, thermal and geometric characteristics may be imposed to find resistance, as an object's resistance is proportional to its length, inversely proportional to its cross-sectional area, and is further influenced by its temperature coefficient. With this in mind, components can be designed to exhibit a specific and ohmic resistance. These components are called resistors, which are a fundamental passive circuit component. They come in a motley crew of shapes, sizes, and colors. Standard coloring, numbering, and lettering conventions are used to denote a resistor's nominal resistance value, depending on its form factor. Recall then the LED. The current through the circuit may now be controlled. This is a 470 ohm resistor, which should draw a current of about 27 milliamps. Success. Yet this is but a simple application of resistance, although it is foundational in the design and analysis of circuits.